So, say we want to find the root locus for this system. Let's start by finding the finite poles and the finite zeros. Basically, the poles and zeros are the values for which the numerator and denominator will be equal to 0, the values of s. And then this is going to help us determine how our system behaves. So, for the finite poles, the values of s for which the denominator equals 0. This is going to be -4 and 0. -4 from this bracket and 0 from this s. And the values for the finite zeros from the numerator, just -8. Okay, the number of finite poles we write as the letter n, and in this case we have 2 of them. And the number of finite zeros we write as m, in this case 1. So now, to find the value of infinite zeros, this is n minus m. The value of finite poles minus the value of finite zeros. So just 2 minus 1, so we have 1 infinite zero. This means 1 asymptote. And since asymptotes going to be symmetric to the real axis, this asymptote is going to be at 180 degrees. Not degrees, degrees. Okay, so what does this value of n tell us? The value of n tells us the number of branches out of which n minus m will end at infinity. So we're going to have 2 branches to draw, out of which 1 will be ending at infinity. You'll see this in our diagrams. Also in this part, I'm going to specify that the angle at which these asymptotes are going to leave the real axis, this is the real, this is the imaginary, so the angle at which they're going to leave, you can find by using this formula. Plus or minus, plus when it's going this way, minus going this way, 180 over n. In this case, we have 2. So 180 over 2 equals 90. So in this case, we know that at 90 degrees is the angle at which they leave the real axes. Complex conjugate poles in opposite direction. We'll see this later on. Okay, next up, we need to find the break-in and breakaway points. So, I've written A of s and B of s, but what are these? Going back here, B of s we denote as the numerator and A of s as the denominator. So, we're looking first at A of s, so the denominator. The denominator is s squared plus 4s after we expand the brackets. And we want to find the derivative of this, so 2s plus 4. Now for the numerator. The value of the numerator is s plus 8, and the derivative of this numerator is just 1. So now, to find the break-in and breakaway points, all we need to do with this is multiply the derivative of a by b and subtract a multiplied by the derivative of b. And once you do this, you have all the values you need here. After the maths, you're going to get s squared plus 16s plus 32. How's this going to help us find the break-in and breakaway points? We're just going to find the roots of this, and those will be your break-in and breakaway points. So, the roots of this system, S1, 2 we're going to denote as, are minus 13.66 and minus 2.34. We have 2 roots. Which one is going to be your break-in point and which one's going to be your breakaway point? Okay, we're going to have to start drawing the root locus diagram for this. So here.